Good day, weather technology students. In this video, we're going to go ahead and do something really cool. We are going to overlay upper air observations with contours from the GFS all on one figure. And so when you often look at maps on the internet, right, for forecast maps or whatever, we're looking just at contours from a model. But there are a few sites out there that actually have the real the observations taken from the balloon launches, or in the case of a surface map, surface observations, with computer-drawn contours over them. And so we want to go ahead and do that today in this particular video. And so to do so, let's go ahead and we're going to copy over a notebook file. So we're going to open up our terminal window. We're first going to change directories into our working directory. For me, that's MET130 SP21. Just listing the contents there to see what's in there. But ultimately, I want to copy a notebook from Valpo_courses, WeatherTech, notebooks, and then I want something called Upper Air 500 obs_contours. That's what we want here today. So again, putting the dot at the end to call it our same thing. We're going to do a long list in time reverse order, and so we see we've copied it over. And it finally made it into our little left-hand window here. I'm going to go ahead and make this smaller. Open up my obs. First thing I'm going to do is I'm going to go ahead and clear this output here. Must have forgotten to clear it the last time I saved it. Good, I'm set to Valpo Spring 2021 here. Whoops, I opened up the wrong one, that's why. I opened up the observation plot instead of the 500 plots. All right, so what do we got going on here? Really what we're doing is we're combining two different capabilities. We're basically combining the capabilities of the upper air observation plot and our gridded model output plot. So this plot, which ultimately just plots our observations, this plot, which plots our contours, we want to combine elements of these two plots into this third one to plot our observations with contours. So again, we're going to use our date-time functionality here, bring in some Cartopy, some MetPy stuff, some NumPy, here's Siphon for getting our upper air data, and then X-ray for reading in that model data. So let's go ahead and make sure that our kernel is set correctly. Then we're going to go ahead and run this to import all of our packages. Good, and then I'm going to pick a date that's relatively recent to when I'm running this, because the way we have it set up now is to use current GFS data. So February, let's see, what is today? Today's the 23rd when I'm making this. So let's try 12Z. I don't know if this data is going to be there yet, but we can try. Looks like it is. So we are gathering our observation data. So we've used Siphon and our Iowa State Upper Air Archive to gather our data. And then we've added lat/lons to that data set. Here then, now I want to grab our GFS data. So looking for the 1 degree GFS data. And here we're going to subset just over the CONUS, so we have a limited amount of data that we're going to read in. And so we're using this same date from getting our observations to get our gridded data. And now we get to the point of plotting. And so we're going to plot a 500 millibar plot here with our temperature, dew point. Instead of calculating dew point pressure, we're just going to plot dew point, and our height without any formatting here, but we'll change that in a little bit. U and V components of the wind and changing the length of that vector field. So this will plot our actual observations. Then we're going to plot our geopotential height every 60 meters, right? So we're making a list from 0 to 10,000 every 60 meters being what we want to plot using OBS level. So what we've set up here as 500 HPA, we're using in setting our contours. And then we're setting up our LCC projection over an area that's over the continental United States, adding a whole bunch of different layers, adding a good title to it, and then here is the key for our overlay. In our list of plots, we want to plot both our observations and our contours. So otherwise, we've just used our two typical things that we had used to make our plots before, but now we're able to combine them in Map Panel to then plot them on our figure. So let's go ahead and give this a run and see what it looks like. And so it turns out that I'm downloading some things. These are just warnings because we're downloading something to our machine to get the land and the water to appear. And here is our plot with actual observations with geopotential height contours every 60 meters. Now looking at this plot though, I think that those wind barbs are a bit too high, so I want to change that down to 7, since we can change the size of those plots just a little bit. And that I want to format our upper level heights instead of having those. So I'm going to go back to my upper air observation plot, and I'm going to find the one that's set for 500. I'm going to copy that, bring it over here to place it in my program. Then I need to add obs.formats, none for temperature, none for dew point, and height_formats for our height values. So now we're running this. We get our wind vectors that are a bit nicer there, not quite as big and overwhelming, and then our height values now in the appropriate form. It also appears that the text maybe is just a bit too small, so I'm going to shave this back here to maybe an 18 by 18 plot. And I'll see what that looks like. Again, right, trying to balance a bunch of these things. Yeah, that looks a little better. Now, some of my lines here are a bit raggedy here with the 1 degree at 500. You know, that's okay. If I wanted to change this to 300, I just have to change to 300 here. And then otherwise that should carry through, but then I would need to change to 120 meter spacing on my geopotential heights. And I get 300 millibar plot, which is also quite nice here. And so it's nice. We can overlay both our observations with contours. If I wanted to, say, add in temperature contours, we could do that as well. We would just need another set of contour values. So we're going to go ahead and copy and paste this code to add in contours of temperature. And so here it's going to be temperature underscore isobaric. And then we would need to change our range here. We're going to go minus 60 to 60 by 5. And then I need to change my units, contour dot plot underscore units equals deg C, because of course in GFS those are going to be in Kelvin. And I need to change it to a different name and then add the second contour into my plot. And so let's see if I've done all those things correctly. Okay, yeah, I've done it correctly, but I've got another solid black line because I forgot to change the color. So line color equals, I'm going to go tab red as my color, and ctrn2.line style as dotted. Let's see what dotted looks like. There we go. That looks pretty good. And so now I've gotten, two sets of contours on my plot. Now I could have made this maybe color filled instead if I didn't want to colorize the land and the ocean to give that kind of nice look to it. And again, you can play with it to your heart's content to do different things, but this is how we would work to overlay both observations and contours. We could do a similar thing for surface maps. We would just need to bring in surface data and then plot surface-based contour values like 2 meter temperatures, 10 meter or 2 meter temperatures, and mean sea level pressure, for example. But note here, I have not plotted wind vectors from the model because I'm only going to want the wind vectors from my observation plots. So that's the basic introduction to being able to overlay observations and contours all in one plot. And that's it for this video. Thanks for watching.